In this lesson you will learn about similar figures. Two figures are similar if they are the same shape but not necessarily the same size. So in these two triangles, triangle ABC and DEF, this symbol is the symbol for similar. And when two figures are similar, the corresponding angles are congruent. Congruent just means that they have equal measure. So since A is written first and D is written first, that would mean that angle A is congruent, and this is the symbol for congruent, to angle D. Since B is written second and E is written second, then we know that angle B is congruent to angle E, and that leaves angle C and angle F. So the first thing we know is that in similar figures, corresponding angles are congruent. The second thing we know about similar figures is that corresponding sides are in proportion. So if I take side AB and ED, AB over ED is equal to AC over DF. And that's equal to BC over EF. So to illustrate this better, I'm going to pick numbers for triangle ABC. So I'm going to say that this side is 3, this side is 4, and this side is 5. If I double all of these values and get 6, 8, and 10, AB over ED is equal to 4 over 8. AC over DF is equal to 3 out of 6. BC over EF is equal to 5 out of 10. So they're in proportion because all of these fractions reduce to 1/2. So when it asks for the ratio of ABC to DEF, we can pick any one of these three sides that we looked at in the corresponding sides, or we can just say that it's equal to 1/2. But be careful that you look at the order correctly. If they ask for the ratio of DEF to ABC, then it would be 2 over 1. So in these two triangles, it's asking for the ratio of ABC to DEF. So if I take side AC and write it over DF, it's equal to 2 over 2, which reduces to 1 over 1. Or if I took side AB and wrote a fraction and compared it to DE, I would get 3 out of 3, which also reduces to 1 over 1. And I could have also taken BC to EF. So in all of these ratios, they all reduce to 1 over 1. So the ratio is 1 to 1. So when the ratio is 1 to 1, not only are the figures similar, but they're also congruent. And congruent just means that all the sides and all of the angles are the same. So the directions are to find the value of x. And when you're finding the value of x for similar figures, you want to set up a proportion. So I am given side AB and side DE. So I'm going to take AB over DE, and then I'm given side BC, so side BC, and I'm given side EF is the one that I'm actually trying to find. So I'll set this equal to BC over EF. And once I have my proportion set up, I just plug in the numbers. So 12 over 15 equals 18 over x. And when your proportion is set up, you cross multiply, starting with the diagonal that has the variable, and I get 12x. And then I multiply 15 times 18. 15 times 18 is 270. And here's my new equation. So to solve for x, I divide both sides by 12. So if I take 12 and divide it into 270, "12 goes into 30 twice, and I get a remainder of 6. So I have x is equal to 22 and 6 over 12, which reduces to 22 and 1/2. For number 2, figure LMNO is similar to PQRS. So I'm given side LO, and I'm also given side PS. So I start with LO over PS, and I set it equal to side ON. ON is here, or NO, and I'm finding side RS. So I set it equal to NO over RS. And once I have my proportion set up, now I just fill in the numbers. So it's 32 over 28 is equal to 36 over x. Now you can cross multiply here, but if you'd like, you could reduce the 32 and 28 by 4. So when you divide 32 by 4, I get 8. 28 by 4, I get 7. You don't have to do this, it'll just make the calculations easier. And if I rewrite this before I cross multiply, I start with the diagonal that has the variable. So I have 8x, and then I multiply 7 times 36. And my equation is 8x equals 252. And then I divide both sides by 8. So in number 2, we have figure LMNO is similar to figure PQRS. So starting with LO, I have side LO, and it corresponds to the letter PS in the second figure. So my first fraction will be LO over PS, and then the second fraction, I'm given side NO, which is 36, and I want to find x. And NO are the last two letters, RS are the last two letters in both. So it's NO over RS. So this is just the setup, the proportion setup, and now I fill in the numbers. So I have 32 over 28 equals 36 over x. Once I have it set up, I can cross multiply, but before I cross multiply on this one, notice how this first fraction, 32 over 28, I can actually divide both of the numbers by 4. And by doing that, it's going to make the numbers much simpler. So before I cross multiply, I'm just reducing it, and then I rewrite the fraction. And now I'll cross multiply so I don't have to deal with such large numbers. Starting with the diagonal that has the variable, and then 7 times 36, and then I divide both sides by 8. So I take 8 into 252, so I get x is equal to 31 and 4/8, and 4/8 reduces to 1/2. So 31 and 1/2. For number 3, we have triangle SKT and SAE. For this one, I'm going to take out triangle SKT and redraw it separately, and label this side 6 and this side X. So I just took this smaller triangle. Now I'm going to draw triangle SAE, which is the larger one. And when I draw SAE, I have AE is 24, but then side SA is a combination of the X and the 16. So I would write that side as X plus 16. So by drawing them separate, I think it's easier to see that side SA is the sum of x and 16. Be careful that you don't write 16x. If you write 16x, then you're saying that you're multiplying the two sides together. You don't want to multiply them, you want to add it together. And now if I look at my triangle, I have side SK and SA. So my proportion will start out as SK over SA. And then I have KT. KT are the last two letters. AE are the last two letters. And now I just fill in the numbers. So SK is X. SA is X plus 16. KT is 6. And AE is 24. So on this one, it doesn't matter which diagonal you start with because both of them will have a variable. So I'm just going to start with this one. So when I cross multiply, I lose the fraction. 6 times x plus 16, and then this diagonal is 24x. So cross multiplying gets rid of the fractions. I place an equal sign in between, and to solve for x, I will distribute the 6 first, and I get 6x. 6 times 16 is 96. And then to solve for x, I want to get my variables together. So I subtract 6x from both sides, and I get 96 equals 18x. So now coming up here, I'll reverse the order. 18x equals 96. And when I divide both sides by 18, I get x is equal to 96 over 18. So we can go right to long division. Or what we could do is both of these numbers are even, so we can divide them both by 2. And if I divide them both by 2, I get x is equal to 48 over 9, which does not reduce, so I could change this to a mixed number. 9 divides into 48 5 times without going over, with 3 left over. And 3/9 reduces to 1/3. So it's 5 and 1/3. For this picture, we're given side KA. KA corresponds to IE. So I start my proportion as KA over IE. And then the other side I'm given is KT. KT are the first and last letters in the first triangle. I want to compare that to IT. So the second fraction is KT over IT. So once you have your proportion set up, you just fill in the numbers. So it will be 8 over 18 equals 6 over x. And if you'd like, you don't have to do this, but 8 and 18 can both divide by 2. So when I do that, my numbers will be smaller. 4 over 9 equals 6 over x. And now I cross multiply. Then I have 4x. And then 6 times 9 is 54. So cross multiplying, the fraction is gone. And now I have an equal sign in between 4x and 54. I divide both sides by 4. And I get x is equal to 54 over 4. Both numbers are even. You can go right to the long division, or you can divide both numbers by 2, and we get x is equal to 27 over 2. And if we convert 27 over 2 into a mixed number, we would get 13 and 1/2. So 27 over 2 is correct too. 13 and a half is another way to write the answer. And for number 5, we have LRIN, the large rectangle, is similar to ORAE, the smaller rectangle. So I'm going to redraw these two shapes so that they're not overlapping. So this is ORAE. Just be careful that you don't put the letters in the wrong place. So this is ORAE, and this one is LRIN. And OR is 20, RA is 12, RI is 12 plus 14, which is 26, and then LR is x plus 20, and I write it just like that as x plus 20. Be very careful that you don't write 20x. You're not multiplying, you're adding the two parts together. And I am given side OR and LR. So that's my first proportion, OR over LR. Then I have side RA, and RA are the middle two letters, RI are the middle two letters, so I want to take RA over RI. And now I just plug in the numbers. OR is 20, LR is x plus 20, RA is 12, and RI is 26. place an equal sign in between, and we're ready to cross multiply. But before I do that, I notice that 12 and 26 are both even, so let's divide them both by 2. This way the calculations are simpler, and I'll rewrite it again as 20 over x plus 20 equals 6 over 13. And when I cross multiply, I start with the diagonal that has the variable, and then 20 times 13 is 260. I distribute the 6. 6x plus 120 equals 260. And I get 6x is equal to 140. I divide both sides by 6, and I get x is equal 140 over 6. So again, on this one you have a choice. You can go right to the long division, but I notice that they're both even, so I can divide both numbers by 2, so that I get x is equal to 70 over 3. And this one I'll show the work for the conversion. 3 divides into 70. We start with the 7, and then 3 divides into 10 3 times, with a remainder of 1. So either 70 over 3 or 23 and 1/3.